In this video, we're going to look at a process you can use to find the highest common factor and lowest common multiple of any pair of numbers. So I'm going to go through these pairs, 105 and 126 and 450 and 1500. Before we get into the process, let's remind ourselves what the highest common factor and lowest common multiples are by doing some smaller examples. So the highest common factor, I've abbreviated to HCF, of 8 and 12. 2 is a common factor of 8 and 12. So a common factor is a number that divides both of these numbers, or is a factor of both of these numbers. So 2 is a factor of 8 and 2 is a factor of 12. It is not the highest common factor. The highest common factor is the highest number that is a factor of both. And in this case, it's 4. 4 is a factor of both 8 and 12, and there's no higher factor. Okay? For the lowest common multiple, abbreviated to LCM, we want to find a multiple of 2 and 3 that is the lowest possible common multiple. So a common multiple of 2 and 3 is 12. It is not the lowest common multiple. That would be 6. So 6 is the lowest number that is a multiple of both 2 and 3. In other words, 6 is in both the 2 and the 3 times tables. Okay, so let's go through the process now. We want to find the highest common factor and lowest common multiple of 105 and 126. To start with, we want to find the prime factors of each number. I went through this in a previous video if you want to check out how to do that. I'm going to start by dividing 105 by 5. So this is going to be 5 times 21. And then I can write that as 3 times 5 times 7. So they are the prime factors of 105. 126, I'm going to start by dividing by 2. That's the easiest place I could start. This is going to be multiplied by 63. Then 63 is 9 times 7. So I'm going to write that as 2 times 9 times 7. And then 9 is 3 squared, so I can write this as 2 times 3 squared times 7. Okay, now I have the prime factors of both numbers. Let's start with the highest common factor. Okay, of these two numbers. So for the highest common factor, you want to take the primes that are common to both numbers. So 2 is in 126, it is not in 105. So 2 is not going to be in the highest common factor. 3 is in both. So 3 belongs in the highest common factor. Not 3 squared, because we only have 1 3 in 105. And then 7 is also in both. Okay, so there we have the highest common factor already. That's going to be 3 times 7, which is 21. Done. Okay, lowest common multiple. For this, we want to take the primes with the highest powers. So I like to think of the lowest common multiple as kind of a battle between the primes. So this 2 here, this prime in 126, it's doing battle with any 2's in 105. There are no 2's in 105, so this 2 automatically wins. It wins its place in the lowest common multiple. Okay, so 2 is going to be in there. 3 squared is battling with the 3 in 105. 3 squared has a higher power, so it wins, right? So we've got 3 squared in the lowest common multiple. 5 is fighting with any 5's in 126. There are no 5, so 5 wins. And then 7 is fighting with 7. That evenly matched, so that's a tie. So 7 is also in the lowest common multiple. So here we have the lowest common multiple, which is 2 times 3 squared, or 9 times 5 times 7. So that's going to be 18 times 35. And let's do some quick maths. Let's think of that as 20 times 35 minus 70. So that would be 700 minus 70, 630. Okay, you could also work that out using long multiplication. It's always good practice to get some mental maths in where you can. Okay, so that's the process. Again, for the highest common factor, we want the primes that are common to both numbers. For the lowest common multiple, we want the primes with the highest powers. And if you're struggling to remember that, just remember that the highest common factor must be lower than both numbers because it's a factor of both numbers. It's either equal to the lowest number or less than the lowest number. Okay, let's go through it again. Maybe you can give this one a go yourself, if that made sense to you. So first we want the prime factors of 450. I'm going to start with 45 times 10. and then 45 is 5 times 9, and then 10 is 2 times 5. And then I'm going to write this as 2 times 3 squared times 5 squared. Okay, then the prime factors of 1500. I'm going to start with 15 times 100. Then 15 is 3 times 5, and then 5 times 20. Let's keep breaking it down. 20 is 4 times 5, or in other words, 2 squared. And then we'll have 3 5, so that's going to be 3 times 5 cubed. 5 times 5 times 5, same as 5 cubed. Okay, now we have the prime factors. Let's go through the process again. Remember, the highest common factor is the primes that are common to both. So here we have a 2 in 450, and we have a 2 squared in 1500. 2 squared is not common to both. Only one lot of 2 is common to both. Okay. Then we have a 3 squared and a 3. We take the 3 that is common to both. And then 5 squared and 5 cubed. 5 squared is, contained within 5 cubed. So 5 squared is common to both. Okay, so then we have our highest common factor of 6 times 25, which is 150. And then the lowest common multiple, again, this is like the battle between the primes. Which one has the higher power? 2 squared versus 2. 2 squared has a higher power. 3 squared versus 3. 3 squared has a higher power. And then 5 cubed versus 5 squared. 5 cubed wins that battle. Okay, then we just need to work this out. So this is going to be 4 times 9 times 125. Then this is going to be 36 times 125, which is 3600 plus 30 times 25, 750, plus 30 times 5, 150. So I didn't fully do that in my head, but that would be 4,500. Okay, and I ran out of room there, but well, there's the answer up there. Okay, so hopefully that process made sense. And you can do this with any pair of numbers, or even more numbers, like you could do this with 3 or 4 numbers, but there is a limit, right? You can imagine if these numbers get so big that you can't easily find the prime factors of them, this process just gets basically harder the larger the numbers get. But for numbers of a certain size, this is a process you can use. Okay, so highest common factor, the primes common to both, and lowest common multiple, the primes with the highest powers. That's how you're working those out. Okay, hopefully that was useful to you. Thanks for watching. Please leave a like if you appreciated this video, and I'll see you in the next one. Bye for now.